What if I told you that time might not be real, at least not in the way you think it is? It's the one thing that runs our lives every single day. It ages our bodies, helps us grow, and creates the memories we cherish so deeply. Time is our constant companion from the moment we are born. It wakes us up in the morning and sends us to bed at night. It's the ticking of a clock on the wall, a silent reminder of each passing moment. We all experience it, yet it remains one of the greatest mysteries of all. We feel time in so many different ways. A long school day can feel like it lasts forever, but a fun afternoon playing with friends can vanish in what feels like an instant. Time seems to stretch and shrink, all depending on what we are doing or how we are feeling. It's a puzzle that has fascinated people for thousands of years. From the earliest humans watching the sun rise and set to the brilliant scientists of today, we've always looked up and wondered, what is this force that guides everything we do? Have you ever stopped to really think about it? It's not something you can hold in your hand. You can't see it or touch it, yet it is everywhere. It's in the changing seasons, from the green leaves of summer to the bare branches of winter. It's in the way a tiny seed grows into a tall tree. Time is the silent storyteller of our world, and every tick of the clock is a new word in its endless tale. It connects every single one of us, no matter where we live or who we are. So, get ready to dive deep into one of the most fascinating questions ever asked. We're going on a journey to explore this incredible mystery together. We'll look at how people first started to measure it using shadows and sand. We'll see what the greatest minds in history have discovered about its secrets. This adventure will take us from our everyday lives all the way to the edge of the universe. Let's begin to unravel the amazing and wonderful story of time. Our journey starts with a simple question that even the smartest people struggle to answer. What is time, really? We use it to organize our day, scheduling our meals and our sleep. We celebrate birthdays, marking another year of our lives passing by. Clocks and calendars are our maps, helping us navigate through the weeks and months, but these are just tools we invented to measure something we don't fully understand. They're like rulers for a thing that has no shape or size. Time itself is far more strange and wonderful than just numbers on a screen. For a very long time, people believed that time was like a great river. They thought it flowed forward at a steady pace, the same for everyone, everywhere. A minute on Earth was a minute on the moon, or a minute on a distant star. It seemed simple and absolute, a universal clock ticking for the entire cosmos. This idea made sense for our daily lives and helped us build our societies. But then, a brilliant scientist came along and changed everything we thought we knew about time. His ideas turned our understanding completely upside down. That scientist was Albert Einstein. He showed us that time is not a straight, unchangeable river. Instead, it's more like a flowing, stretchy fabric that is woven into the universe itself. He called this fabric space-time. According to his mind-bending theories, this fabric can be warped and bent by massive objects like planets and stars. And what's even stranger is that time can speed up or slow down. The faster you move through space, the slower you move through time. It sounds like something from a science fiction movie, but it is real. This idea, known as time dilation, means that time is personal. Your time is not exactly the same as my time. An astronaut zooming through space in a rocket actually ages a tiny bit slower than their friends and family back on Earth. Scientists have even proven this using super precise atomic clocks on airplanes and satellites. This discovery opened up a whole new world of possibilities and even bigger questions. If time isn't constant, what else don't we know about it? Our journey into this mystery is just getting started. What is time? It's not something you can grab or see. Time is how we measure change. Early humans looked to the sky. The sun and moon became humanity's first clocks. They created sundials and hourglasses. But even with all these clever devices, we are still just measuring something. Science has shown us that time is a fundamental part of reality. For most of human history, we believed time was absolute. It was like a giant invisible clock for the whole universe. But as our understanding of the universe grew, so did the mystery of time. Astronomers realized they were seeing light that had traveled for millions of years to reach us. When you look at a star, You are not seeing it as it is right now. You are literally looking into the past. This showed us that time and space are connected in a profound way. The universe itself became a kind of time machine. The simple idea of a universal clock started to crumble. It was becoming clear that to truly understand time, we had to look beyond our clocks and calendars. A new chapter in the story of time was about to be written, not on Earth, but in the stars. One of the biggest puzzles about time is why it only seems to move in one direction. We call this the arrow of time. Time always moves forward, never in reverse. This is connected to entropy, or disorder. The laws of physics say that in a closed system, like our universe, things tend to get more disordered over time. It started in a very ordered state at the Big Bang, and has been getting more disordered ever since. This increase in disorder is what gives time its direction. The real driver of time might be this unstoppable march toward disorder. It is a fundamental property of our universe. The mystery of why time has an arrow is one of the deepest in all of science. In 1905, Albert Einstein changed how we understand the universe. He proposed that time isn't separate from space, but woven together into space-time. Imagine space-time as a trampoline. A bowling ball in the center warps the fabric. Massive objects like planets do this to space-time, creating gravity. Einstein's theory of relativity also predicted that time is not absolute. Time can slow down or speed up depending on your speed and how close you are to a massive object. Time is relative depending on your motion and location. It's all woven into the fabric of existence. Let's explore the twin paradox, a famous thought experiment. Imagine twins, Anna and Ben. Anna, the astronaut, boards a super-fast spaceship. Her mission, a distant star and back. Ben stays on Earth. When Anna returns, Ben is old, but Anna is still young. Time slowed for her due to her speed. This is time dilation, a consequence of relativity. The faster you move, the slower you move through time. Scientists have confirmed this with atomic clocks on jets and satellites. Time is not the same for everyone. Gravity also has a powerful effect on the flow of time. The more massive an object, the deeper the curve it creates in space-time. Einstein realized this curving of space also means a curving of time. The stronger the gravity, the slower time passes. Gravitational time dilation is a crucial part of our modern technology. The Global Positioning System, or GPS, would not work without accounting for Einstein's theories, because time runs slightly faster for GPS satellites. Let's journey to the most extreme places in the universe, where physics are pushed to their limits. We are talking about black holes, the cosmic monsters of the galaxy. A black hole's gravity is inescapable. Not even light can break free once it crosses the event horizon. Time gets really weird here. The immense gravity warps space-time so dramatically that time itself begins to slow down. Imagine a friend approaching a black hole. From a distance, their movements slow, their clock ticks slower, and they appear frozen at the event horizon. But for them, time feels normal as they fall into darkness. This shows how relative and flexible time truly is. The universe is far stranger than we can possibly imagine. The strangeness of time doesn't just exist near black holes. It also lives in some very big ideas about the universe itself. One of the most mind-boggling concepts is called eternalism, or the block universe theory. This idea suggests that our common perception of time flowing forward is just a human experience, not a fundamental feature of reality. Imagine the entire history of the universe, every moment from the Big Bang to the very end of time, as a single giant block. In this block, the past, the present, and the future all exist simultaneously. Think of it like a movie on a DVD. You can skip to any scene you want, forward or backward. All the scenes, the beginning, the middle, and the end, are already there on the disc, existing at the same time. The block universe theory suggests that reality is like that DVD. The past isn't gone, and the future isn't something that hasn't happened yet. Instead, all moments, every event that has ever happened or ever will happen, are just different locations in this four-dimensional block of space-time. They are all equally real and permanent. According to this view, our feeling of time passing is just an illusion created by our consciousness. We are like a spotlight moving along the length of the movie reel. We only experience the single frame that we are currently illuminating, which we call the present. The frames behind us are the past, and the frames ahead are the future. But the entire reel is already there. This means that the dinosaurs still exist in their part of the space-time block, and your future birthdays already exist in another part. It's a staggering thought. This idea comes directly from Einstein's theory of relativity, which treats time as another dimension, just like length, width, and height. If this theory is correct, it changes everything. It means that there is no special now. Your now is just your location in space-time. It also suggests that the future might already be written, set in stone within this cosmic block. While many scientists are still debating this theory, it opens up profound questions about free will and destiny, challenging our most basic assumptions about our journey through time. Some physicists and philosophers ask, what if time doesn't exist? What if our brains create time to help us make sense of the world? Our brains organize sensory information into a sequential narrative. Time, in this view, is like an operating system for our consciousness. Quantum physics suggests time might be an emergent property. The concept of the arrow of time seems to disappear at this tiny scale. So, is time real, or is it a grand story our minds tell us? It remains one of the deepest mysteries in all of science. Your brain has its own internal clock, a biological timer that regulates your daily life. This inner timer, known as the circadian rhythm, controls our sleep-wake cycles, hunger and body temperature, synced to the Earth's day and night. Scientists believe we also have other internal timers that help us judge shorter durations. Our brain's perception of time is flexible and influenced by our experiences. New and exciting experiences create richer memories, making them feel longer. Our perception of time isn't a perfect reflection of reality. It's a subjective story created by our minds. Our brains are the true timekeepers of our lives. Time seems to fly when you're having fun, but drags when you're bored. Why? When we're deeply engaged, our brains focus on the activity, not the clock, so time feels like it speeds up. Boredom or anxiety makes us hyper-aware of every second, stretching time out. Our emotions shape how we experience time. Joy and excitement make it race, while boredom and fear slow it down. The clock may say 60 minutes, but our brains can make it feel much longer or shorter. In moments of danger, like a near miss in traffic, time can seem to slow down as our brains record every detail. This isn't magic. It's our brain's way of helping us survive and remember. So when time drags or flies, it's your mind interpreting reality, not the universe changing speed. Our journey through time is unique, shaped by our feelings and experiences. Time is personal, an adventure that's different for everyone. Why does time seem to speed up as we get older? For a child, a year is a huge part of their life, full of new experiences and memories. For adults, each year is a smaller fraction of their life, so it feels shorter. Novelty stretches time. New experiences create rich memories, making days feel longer. Routine compresses time. Familiar days blend together, making months and years seem to vanish. As we age, life often becomes more predictable, and time seems to slip by. The secret to slowing down time? Keep learning, exploring, and seeking new adventures. Fill your life with memorable moments, no matter your age. Our perception of time is shaped by how we live, not just by the calendar. Make every year count by making it memorable. Can we travel through time? Science says, to the future, yes, sort of. Einstein's relativity shows that time slows down at high speeds or near strong gravity. Travel near light speed, and you'll age slower than people on Earth, returning to find decades have passed. Orbit a black hole, and an hour for you could be a century for everyone else. These aren't just theories. Astronauts on the International Space Station age a tiny bit slower than us. The challenge isn't the physics, but the technology. We can't yet build ships that go fast enough or survive black holes. Still, the door to the future is open, at least in theory. Time travel to the future is a real consequence of our universe's laws. We just need the tools to make it practical. The future is waiting, if we can figure out how to reach it. For now, we're all time travelers, moving forward 1 second at a time. Traveling to the past is a much bigger challenge and full of paradoxes. The grandfather paradox. If you change the past, do you erase your own existence? Most scientists think backward time travel breaks the rules of cause and effect. Some theories suggest wormholes could connect different points in time, but they require exotic matter we've never found. Other ideas say you couldn't change the past, or you'd create a new timeline instead. For now, time machines are science fiction, not science fact. But exploring these puzzles pushes the boundaries of what we know. The past remains a mystery, one that keeps inspiring new questions. We've explored time from ticking clocks to the edge of black holes. Time isn't just a number. It's woven into the universe, shaped by speed, gravity, and our own minds. Einstein showed us that time is relative, unique for each of us. Our emotions, memories, and experiences all color how we feel time's passage. The past, present, and future might all exist together, or time could be an illusion. From the arrow of time to the mysteries of relativity, time connects everything in the cosmos. Even with all we've learned, time remains one of science's greatest puzzles. It's the silent companion to every moment, linking us to the universe. Our journey through time is both personal and cosmic. The mystery invites us to keep asking, keep exploring, and keep wondering. What is time, really? We still don't fully know. Is it a force of nature or an illusion of the mind? Does the future already exist, or do we create it? Every discovery brings more questions. Science is a never-ending adventure. The mystery of time reminds us to stay curious and keep exploring. Our experience of time is precious. Each moment is part of our story. How we spend our time gives our lives meaning. Understanding time helps us appreciate every second. Maybe we don't just move through time, maybe we shape it as we go. The universe is full of secrets waiting to be uncovered. Keep asking, keep exploring, and never lose your sense of wonder for